Okay, so let's look at number 1. Suppose you walk 15 meters straight west and then 21 meters straight north as shown in the figure. So we're asked to find how far are you from your starting point in meters. So we need to find the resultant displacement from the starting point here to the ending point here. Okay, so this is a vector problem. You have this vector and then you have this vector, so you need to add the two vectors. Okay, so when the two vectors are perpendicular to each other, you can get the magnitude of the third vector by using Pythagoras theorem. Okay, so to find the magnitude of the third vector r, you can use square root of the first vector squared plus second vector squared. This works only when the two vectors or two components are perpendicular to each other. Okay, if the two vectors are not perpendicular, then we cannot do that. So a squared is 15 squared, and then b squared is 21 meters squared. Okay, so that gives us the resultant vector. This will give us the net displacement, the magnitude. And we also need to find the angle, and we want to find the angle with respect to the y-axis, okay, to the north. So this is north, so this is what we want to find. And if you look at this triangle, this angle and this angle will be equal. Okay, they are alternate angles. So that means if we take the tangent theta, the tangent theta would be opposite, which is a vector, the magnitude of vector a over the magnitude of vector b. So then you can find the angle theta by taking the tan inverse of a over b. Okay, so tan inverse of a is 15 meters and b is 21 meters. Okay, so that'll give you the angle. Now let's look at problem number 2. So on problem number 2, we are given two vectors VA and VB, and then the resultant of the two vectors, which is V total. So we are given the angles theta 1, theta 2, and then we are asked to find magnitude of VA in meters per second. So we need to find VA, its magnitude, and then we also need to find the magnitude of VB. So VB is what? And then let's see what else we need to find. Yeah, so there are the only things we need to find. So to find the magnitudes of V and VB, the easier way would be to use something called the law of sines. Okay, you might have seen this in trigonometry. Let me just review that. So if you have a triangle, and let's say the sides of the triangle are A, B, and C, and then the angle opposite to this side is, let's say, theta A. The angle opposite to this side B is, let's say, theta B, and the side opposite to this side C is theta C. Okay, so the law of sines tells us that the ratio of the side A over its sine of the opposite angle is equal to the ratio of side B over sine of its opposite angle, which is theta B, is equal to the side C over sine of its opposite angle theta c. Okay, so that's the law of sines. So we'll use this law to get these quantities. Okay, so to use the sign of the law of sines, we need to get this angle also. These are given, theta 1 and theta 2. So this would be the sum of the three angles in a triangle is 180 degrees, and this angle would be 180 minus theta 1 plus theta 2. Okay, that means 180 minus 25 degree minus 15 degrees, which is 180 minus 40 is 140 degrees. Okay, so let's use the law of sines for vector A first. So vector A has the magnitude VA, and sine of angle opposite to that side, sine of angle opposite to this side is theta 2. Okay, so this is the side we are talking about, and the angle opposite to this one is this theta 2. So sine theta 2 is equal to, now I cannot use theta b here because I don't know anything about theta, I don't know anything about VB. So let's not use VB. Instead, let's use V total because we are given V total. Okay, so magnitude of V total over, so V total is this side, and the angle opposite to this side would be this 140 degrees. Okay, so sine 140 degrees. Okay, so we want to find VA. We're given V total. V total is known. Theta 2 is also known, and we have sine 140 degrees. So everything is known except VA. So you can find VA by plugging the numbers. Okay, and then to find VB, we'll use the same law here. So choose the side VB. So this is VB. So VB, and then sine of the angle opposite to this side. So this is VB, and the side opposite to the angle opposite to that is this angle. Okay, theta 1. So theta 1 is equal to, now again you can either use VA because here we already found VA, or you can just use the given vector, which is V total. Okay, and sine of angle opposite to V total is sine 140 degrees. Okay, so that will give you this VB. Everything here is known except VB, and you can plug in the numbers and find VB. Let's look at number 3. Okay, number 3 is similar to number 1. So we have this vector given. Actually, this is a little bit different from number 1 because this involves just resolution of a given vector. So we have this vector D, and its magnitude is 105 meters, and it is at 15 degrees from y-axis. So here we are asked to find an expression for x component vector dx in terms of d, theta, and unit vectors I and j. So to find the x and y components, we just need to project this on x and y axis. So when you project this on y axis, so this will give us the magnitude of this vector dy. Okay, so the y component of the vector. And if you project this on x-axis, then this length will give us the x component of this vector. So that's dx. Okay, so we want to find dx and dy. So we need to use trigonometry here. This length dx and this length is same, so you can also consider this to be dx. Likewise, this is already dy, so we can just assume this triangle, okay, the upper triangle. So we want to find dx. Let's find the ratio sine theta. Okay, so sine theta would be opposite, which is dx, over hypotenuse, which is d. Okay, so here we only want to write the magnitude. We don't need to write the vector here. Okay, we are dealing with the values or magnitude only. So that means dx would be d sine theta. Okay, and we want to write this in terms of the unit vectors I and j, which is basically dx is, we need to think about, when we write unit vectors, we need to think about which way it is pointing. Okay, so this dx is on the left side of the y-axis. So whenever we have the component on the left side of the y-axis, it is negative, okay, because this side is negative x. Okay, so this one is negative positive x and positive y. This side is negative x and positive y. Okay, this side is negative x, but it has positive y. This side has negative x and negative y. Okay, both x component and y component both are negative in this quadrant, and on this quadrant we have positive x is pointing to the right, and y is pointing down, so y is negative. So our x component is pointing to the left, so we have minus d sine theta, and to denote that it's pointing to the left, so we need to use this I hat. This I hat means pointing along x direction, and this negative sign tells us it's pointing to the left. Likewise, let's take the ratio of cosine theta. So cosine theta would be adjacent of this angle is dy over hypotenuse, which is d. Then we get dy is d cosine theta. Okay, just rearranging the terms. And in terms of unit vector, so dy would be it's pointing up, so we don't need to use minus sign. So d cosine theta, to indicate that it's pointing up, we use this j hat vector. And on part C, it's asking us to write the vector d in terms of the components and I hat and j hat vectors. Okay, so this is part A, part B, and on part C, this vector d is x component, which is d negative d sine theta I hat plus d cosine theta j hat. Okay, so one way to remember which one gets sine and cosine is to look at which side is touching the angle. Okay, so if we are talking about this side, okay, this y component, so in this case y is touching this angle, so the side that touches the angle gets the cosine. Okay, so this one becomes d cosine theta, and the side that is away from the angle, so this side, which is the x component, is away from the angle, so the one that is away from the angle gets sine. Okay, sine of the angle d theta. Again, the side that is touching this angle gets cosine, and the side that is away from the angle gets sine. Okay. And the other thing is, if it is pointing to the left, you need to put minus sign here. If it is pointing to the right, then obviously it's positive. If it is pointing up, it is positive. If it is pointing down, then you need to consider the negative sign. Now let's look at number 4. So here's number 4. It says suppose you walk 15 meters straight east. So 15 meters to the east, and let's say this is our coordinate. So this is north or y-axis, this is east or x-axis, and then 20 meters straight south. Okay, so then you move down. So this is south, so you move down. That's 22 meters. You may want to write a little bit longer. Okay, so that's 22 meters. How far are you from your starting point in meters? So you need to find this vector. Okay, so again, like I said before, when the two vectors are perpendicular to each other, we can use Pythagoras theorem to find the resultant. So our resultant would be square root of 15 meters squared plus 22 meters squared. Okay, that gives us the resultant. That tells us how far you would be from your starting point. And then at what angle in degrees south of east is a line connecting your starting point to the final point. South of east is this angle. Okay, so south of east. Let's take the tangent theta. Tangent theta is the ratio of perpendicular, which is 22 meters, to the adjacent, which is 15 meters. So then theta would be equal to tan inverse of 22 meters over 15 meters. Okay, so that's the angle. Okay, so let's look at number 5. So on number 5, we are given different speeds and angle also 45 degrees, and for each of these speeds we are asked to find the range. Okay, different ranges. So let's say for 30 meters per second, so v is 30 meters per second. Our angle is 45 degrees, and we want to find the range r, which is the horizontal displacement. Okay, so that's also delta x. So this vector v can be resolved into two components. So we have this vector v at 45 degrees. We have this x component, which is v cosine 45 degrees. Like I said before, this side that is touching this angle gets cosine. Okay, and the y component, this is the y component, or this one, which is away from the angle, so this gets sine angle. Okay, sine 45 degrees. So for the range is a horizontal motion. We need to consider the horizontal velocity. Okay, and in the last lecture we talked about the horizontal motion being a constant motion. Okay, so there is no acceleration involved in the horizontal motion. That means there is only one formula for horizontal motion, that is delta x is equal to v delta t. Okay, or you can say range is equal to velocity times delta t. Okay, this comes from this formula. So definition of velocity, when there is no acceleration, v is distance over time. Okay, so here this is x motion. That means we need to write this x velocity or x component of the velocity, and x component of velocity is this v cosine 45 degrees. Okay, so v cosine 45 degrees times time. Okay, v is known, 30 meters per second, and cosine 45 degrees, you can find that, but we do not have time. Okay, time is not given. That means we first need to find the time to solve this problem. So the way to find the time is look at the vertical part. Okay, so for vertical motion, the velocity would be, initial velocity would be that. Okay, so for vertical motion, our VIY, I'm writing subscript y here to denote that it's a vertical motion, is v sine 45 degrees, and our displacement in the vertical motion would be 0. Okay, it starts from the ground level and then ends to the ground level, so that's delta y is 0. And then acceleration is always negative 9.8 meters per second squared. That's always true for vertical motion. And we want to find t, so we need to decide which formula we want to use. So I'm going to use delta y is equal to vi t plus 1/2 at squared. Okay, so this delta y is 0. Vi, in this case I would need to write viy here because this is all about vertical motion, so we need to differentiate that this is a vertical motion. So viy is v sine 45 degrees, and then we have t here plus 1/2 9.8 meters per second squared. Actually this is negative because it's pointing down, so its acceleration is negative, and then t squared. Okay, so you solve this equation for t. Okay, I have shown this in previous lecture. You find t, and then you can use that t in this equation, and that'll give us the range. Okay, so that's what you need to find, and you do the same thing for all the different speeds. Okay, this is just for 30 meters per second, and now you need to do the same thing for 40 meters per second and 50 meters per second. Okay, let's look at number 6. So treated as a projectile, what is the maximum range in meter obtainable by a person if he or she has a takeoff speed of 8.2 meters per second? Assume the motion is over level ground and the initial velocity makes an angle of 45 with the horizontal. So this is a projectile problem where the person jumps or takes off at the speed of 8.2 meters per second. So that's equal to 8.2 meters per second. And the person takes off at 45 degrees angle to the horizontal surface, and we want to find the range. Okay, so what's the range of this person? And this is exactly the same kind of problem as number 5. So this is what we want to find. So in this problem, we can first start with the x motion or horizontal motion, and then we can deal with the horizontal vertical part. Okay, so for horizontal motion, so here we have the velocity in this angle, at this angle 45 degrees, so we can resolve this vector into x component and y component. So we have this x component velocity. This x component velocity will move this object in the horizontal direction, and we have this vertical component of the velocity, and the vertical component of the velocity will move the object in the upward direction. Okay, so for horizontal motion, our velocity is vx, which is again the side that touches the angle gets cosine, so vector times cosine 45 degrees. Our vector is 8.2 meters per second, and cosine 45 degrees. That's our x component of the velocity. And range is what we want to find. And for the horizontal motion, there is no acceleration, so we have range given by, this is delta x. So delta x is given by this formula, so delta x over delta t is v, okay, vx. So range is vx times delta t, or you can just write t. Now we know vx, which is that, but we don't know t. So first we need to find the t, and then we can come back to this. Okay, so then let's look at vertical motion. So just like before, for vertical motion, acceleration is always negative 9.8 meters per second squared, and then the vertical displacement is 0, and then the vertical velocity vy I, initial velocity in the vertical direction, is, so this side is away from the angle, so vector times sine 45 degrees. Okay, so to find the time, let's use this formula. So delta y is equal to viy t plus 1/2 a t squared. So the vertical velocity, vertical displacement is 0. viy is v sine 45 degrees times t plus 1/2 negative 9.8 meters per second squared times t squared. So you solve this for t. Okay, again I have shown this in the previous problems in the last lecture, and then you use this t in this expression, and that will give us the range r. Okay, so now let's look at number 7. Looks like this is also a similar kind of problem. So we have a soccer player kicks the ball from a distance 21.5 meters towards the goal. So say that's our coordinate. So the ball is kicked from this corner, and that's the goal post. So it's kicked at the range of 21.5 meters, and find the initial speed. Okay, so we want to find the initial speed at which the ball is kicked. So v is what, and it is kicked at 40 degrees above the horizontal plane or horizontal surface. Okay, let's try it again. So this is 40 degrees. And if it just passes up over the goal 2.4 meter above the ground, okay, so it hits 2.4 meter above the ground, or it passes over the goal that is 2.4 meters above the ground. So how do we find v? So in order to find v, we first need to find either Vx or Vy. If we find that, then we can easily find V, because we know that Vx is V cosine theta and Vy is V sine theta. We know theta. If we could find Vy, then we can use this formula to find V. Likewise, if we could find Vx, then we can use this formula to find V. Okay, so that means we need to find either Vx or Vy. So let's consider the vertical motion. So again, for the vertical motion, A is negative 9.8 meters per second squared. Delta y, what about delta y? So delta y here is not 0, because delta y means final height minus initial height. So look at that. So final height is 2.5 meters above the ground. Okay, so that's 2.4 meters, but the initial height is 0. Okay, that means delta y is 2.4. Unlike in the previous problem, here the net displacement is not 0. Okay, and then we also have what else we have? Okay, that's all we have for vertical motion. So we can use this formula. Delta y is equal to Vi t plus 1/2 at squared. Okay, so let's see. So this is Viy. Now we do not have this quantity and this quantity, so that means there are two unknowns here. Okay, so that means we can, let's plug 2.4 here meters is equal to, this is unknown Viy, and then t is unknown, plus 1/2 negative 9.8 meters per second squared and t squared. Okay, so we cannot find Viy from this equation, so let's just leave it for a second. Now let's look at the horizontal part. Okay, so let's call this equation 1. So let's look at horizontal motion. And for horizontal motion, our formula is range is equal to initial velocity, or x component of the velocity. We don't need to write initial or final velocity here, because velocity is always constant in case of horizontal motion, because there is no acceleration, times t. And so we don't know Vx, we don't know t. Okay, so there are two unknowns, but what we can do is, we have two equations, we can solve these two equations. Okay, we can somehow eliminate t by using these two equations. So let's write this equation in terms of t. T is equal to r over Vx, and let's substitute this expression in this equation 1. So we have 2.4 meters is equal to Viy, t is r Vx. So when you divide 9.8 by 2, you get 4.9. Okay, we have negative here from here. 4.9 times t squared, and t squared is r over Vx squared. Okay, so 2.4 is equal to Viy. I already showed you what VIY is. So that's VIY. Okay, so that's VIY. So V cosine theta, or sorry, V sine theta. So that's V sine theta times R over this Vx is V cosine theta minus 4.9 R Vx is V cosine theta squared. Okay. So now we have everything known in this equation except V. Okay, so our job is to find V. Actually, you can cancel this V and this V. So that's 2.4 is equal to sine theta over cosine theta is tangent theta. And then range is given. Okay, we will use that later. Minus 4.9 R squared over V squared cosine square theta. Okay, now we need to put V on one side and everything else on other side, because the only quantity that is unknown in this case is V. Okay, so let's do that. So we will move this whole thing to the left, and then this one to the right. Okay, so when you move this to the left, this negative becomes positive. So 4.9 R squared V squared cosine squared theta is equal to R tan theta negative 2.4. Okay, and now because we want to get V squared, so we want to do the cross multiplication. So move this to the numerator here and then move this to the denominator down there. So it's just like doing A over B is equal to C. We can write this as A is equal to C times B, or we can write this as A over C is equal to B. Okay, just doing the cross multiplication, or exchanging the denominator to the numerator here and then numerator to the denominator here. So you can get that. So 4.9 R squared over, actually you can leave the cosine square theta here because we need to plug in the value of theta. So this one would be 1 over R tan theta minus 2.4, okay, is equal to V squared. And then to get V squared, so to get V, you need to take the square root of all these terms. So we have 4.9. Now range is given. Okay, you can use that value here. So range is, what's range? So that's 21.5 meters. 21.5 meters, and then we have square over cosine square theta. Cosine square theta is what is the angle for? It's 40 degrees. Okay, 40 degrees, and then R range is 21.5 tangent 40 degrees minus 2.4. Okay, so that gives us V. So you do the calculation, that'll give you V. So now let's look at number 8. A ball is thrown horizontally from the top of a 55-meter building and lands 105 meters from the base of the building. So let's draw a picture here. So that's 55 meter tall building. Okay. And then it lands 105 meters. Okay. So our range here is 105 meters from the base of the building. Ignore the air resistance. Use a coordinate system whose origin is at the top of the building. So we want to consider this as our origin. Okay, so that's what the question is saying. So that's y-axis and that's x-axis, and this is origin. So the question is asking how long is the ball is in air. Okay, so it starts from here and then it ends here. So how long is the ball in air? The ball is in air for the same amount of time as it takes to travel from this point to that level. Okay, from this point to that point. Okay, so the time it takes to cover the range r is same as the time it takes to cover the vertical height delta y, which is also the time during which the ball is in air. Okay, so that means if we could find the time it takes to cover this range or time to travel this height, then that will answer our first question. So let's consider the vertical motion. Okay, so consider vertical motion. So our delta y is final height minus initial height. Final height is, when it is down, it's negative 55 meters and initial height is 0. So delta y is negative 55 meters. And for vertical motion, acceleration is negative 9.8 meters per second squared. And for the vertical motion, it's just like dropping a ball. So when you drop a ball, it starts from rest. So vi, initial velocity in y direction, is 0. Okay, so let's find the time. So to find the time, we can use this formula. Delta y is equal to vi y t plus 1/2 at squared. That's 2. So delta y is negative 55 meters is equal to 0 plus 1/2 negative 9.8 meters squared times t squared. Okay, so you can find time by solving this equation, and that will give us the time for, or time during which the ball is in air. So now let's look at the second part. On the second part, it's asking what must have been the initial horizontal component of the velocity in meters per second. So we want to find Vx. Okay, so for Vx we need to use horizontal motion, and for horizontal motion we only have one equation, that is Vx is equal to delta x times t. Okay, delta x is the range, and we are given the range. Okay, range is 105 meters, and the time to cover that range is same as the time during which the ball is in air, which is the time that we get from the first problem. Okay, so by doing that math, you can get Vx. And then let's look at part part C. What is the vertical component of the velocity just before hitting the ground? Okay, so the ball moves down like that, and then when it hits the just before hitting the ground, this has two components. Okay, so one is vertical component, the velocity that moves it down, so that's v. Oops. Let's see. So that's our ground level, and there is this y component of the final velocity, or the Fy, and then there is this x component also, which is Vx. This x component remains same throughout the motion, whereas this changes at different points. So we want to find this one. We have three formulas again. Okay, just a reminder, we have this formula: V final is equal to V initial plus AT. V F squared is equal to Vi squared plus 2A delta Y or delta X, depending on which direction you are dealing with. And then we have delta Y is equal to Vi YT plus 1/2 AT squared. Okay, we have these three formulas. So this one is also Y, this is also Y. So we need to decide which formula we want to use. Okay, so do we have initial velocity in the vertical direction? Yes, we have. That is 0. And do we have acceleration? Yes, we have acceleration. Do we have time? Yes, we have time. So that means we can use this equation, okay, for part C. So V final Y is 0 plus V acceleration is negative 9.8 meters per second squared, and time is again same as the time that you use here. Okay, and that's squared. No, not square, sorry, there's no square. So you multiply these two numbers, that gives you V final Y. Okay, the answer will be in negative because there's a negative sign here, and that negative sign implies that the velocity is pointing down, or the ball is moving down. And part D is, what is the magnitude of the velocity of the ball just before it hits the ground? So now we need to also find the resultant of these two velocities. So again, we have this vertical component of the final velocity, horizontal component of the final velocity, and by combining those two, we can find the magnitude of this final velocity, okay, V. So we want to find V. So we have one velocity in this direction, which is Vx. This is always same. There is no acceleration, so this is constant. We already know that. Okay, you find that on part B, and then this is you find from part C, and then we want to find the resultant. Now, like I said before, when the two vectors are perpendicular to each other, we can find the resultant of the two vectors by using Pythagoras theorem. Okay, so you can use x component square plus y component squared. That gives us the final velocity. So this is from part B, and this guy is from part C, but you need to square the values you get from B and C. So let's look at number 9. During a baseball game, a baseball is struck at ground level by a batter. The ball leaves the baseball bat with an initial speed V0 of 25 meters per second. So our initial velocity here is 25 meters per second. at an angle of 15 degrees. So that's 15 degrees above the horizontal. Let the origin of the Cartesian coordinate system, Cartesian means x and y coordinate, be the ball's position the instant it leaves the bat. Air resistance may be ignored throughout this problem. So the first question is asking, express the magnitude of the ball's initial velocity Vox in terms of Vo and V theta. Okay, so this velocity is what we call Vo. Okay, so Vo means, sometimes I write Vi. Basically this Vo and Vi are same symbol, okay, for initial velocity. So this velocity is Vo, okay, initial velocity, which is 25. It doesn't look 25 here, so this is 25 meters per second. So we want to express this velocity Vox, okay, which is same as Vix. Sometimes I write Vix for that. So we want to write this in terms of this and this angle. So like I said before, when you throw an object in air at some angle, so this velocity will have x component, which will move the object in horizontal direction, and it will also have this vertical component, which will move the object in vertical direction. Okay. So the vertical one is Voy and horizontal one is Vox. So basically we can use the vector rule. So Vox is the component of this vector and it's touching the angle. So the rule is when it touches the angle, it gets cosine. Okay, again, this is just to memorize which one gets cosine and which one gets sine. You can find that by using a triangle also. But if you don't want to do the detailed derivation, you can just memorize that. Okay, Vox is Vo cosine 45 degrees. And also if you want to know Voy, so Voy is away from this angle, so it gets sine. Okay, so Vo sine 45 degrees. So that's the expression that we want. Okay, it's in terms of V naught and cosine. It's only asking about the symbolic derivation, so we don't even need to write 45 degrees here. We can just write this as Vox is equal to Vo cosine theta, because it says in terms of Vo and theta. Okay, we'll use the values only when we want to find a number. So part B is asking, express the magnitude of the ball's initial velocity, vertical velocity, in terms of Vo and and theta. Okay, so just like that, we want to find Voy, and like I said before, so when the side is away from the angle, it gets sine theta. Okay, so Vo sine theta, that's the expression. And then let's look at part C. What is it asking? Find the ball's maximum vertical height in meters above the ground. Okay, so we want to find the maximum height, this height. So for maximum height, we need to use the vertical motion. Because we want to find what happens as the ball moves up. Okay, so that's the vertical motion. So for vertical motion, our delta y is That's what we want to find. Delta y is y final minus y initial, which is y final, okay, or y max. This y final is the maximum height it attains, and then initial is just 0. This is 0, so delta y is y max. And then a, for any vertical motion, a is negative 9.8 meters per second squared. And then for vertical motion, VOY, initial vertical speed, is VO sine theta, so that is 25 meters per second. Sine theta is 15 degrees. Okay, you can find that. Now you need to decide which formula you want to use to find the maximum height. Okay, so I'm going to use this formula. Delta y is equal to VOY. So in the previous problem I used I instead of O here, but it's same thing. Okay, O is also used for initial velocity. So VOY, or sometimes VIY times t plus 1/2 AT squared. However, we do not have time given. That means we may not be able to use this formula because we know this one, we know that one, but without t we cannot find that. Okay, so that means we don't want to use that. So the next formula we have is delta y is equal to, or we have v final squared is equal to v initial squared plus 2a delta y. Okay, so let's write this in terms of delta y. So delta y is equal to v final squared, just rearranging the terms, v initial squared over 2a. So here we are dealing with the vertical motion, so that means we need to write vy here, and again here we are just calling this v naught. So let's write v naught y. Okay, so delta y is, we got that, y max. So y max is equal to v final. So at the highest point when the ball moves up, okay, just like that, at the highest point it stops momentarily. So we are just dealing with upward motion. Okay, so it moves up, 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 it stops very briefly, and then it moves down, 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 down. Okay, so that means at the highest point its velocity is 0, and then initial velocity is that. Okay, so which is 25 meters per second sine 15 degrees over 2 times a is negative 9.8 meters per second squared. Okay, so do the calculation, you get the maximum height. So that's part C. Let's look at part D. Enter an expression in terms of v theta, theta, and g for the maximum time. So we need to find the time to reach the maximum height. Now we can use the second formula, so the one we used previously. So we have delta y, so we need to use the formula that involves time. So we have two formulas here that involves time. One is this one, VOY t plus 1/2 AT squared, and other one is V final y is equal to V initial y plus AT. So you can use either one, but whichever is simpler, you can just use the one that involves less calculation. So it seems like this is simpler, so I'm going to use this one only. So for maximum time, this thing would be 0, okay, because this is the maximum, this is the speed at the maximum height, so that's 0. And then VOY is the initial velocity, we already have that, which is 25 meters per second sine 15 degrees. Okay, and then that times time. So you do the calculation, no, not that, sorry, that's the VOY, and then we have plus, and then A is negative 9.8 meters per second squared, and then T, okay, sorry, not T squared, just T. So solve this equation and then get T. Okay, that's the time. Oh, by the way, so in this part, it's not asking for the value, sorry for that. It's only asking for the symbolic expression. So we don't want the value, okay? So let me just write the symbolic expression here. If you are asked the value, then you can plug in the values, but we don't need to do that here. So this is just V naught, this is sine theta, plus this is A, this is T. Okay, so we need to rearrange this to write the expression. So we want to write an expression for T. So bring this to the left. So negative V naught sine theta is equal to AT. Okay. So T would be negative V naught sine theta. So sometimes we can write A as negative G, okay, because G is, this 9.8 is written as G because it's this is the acceleration due to gravity. So we can write A as negative G. So here we can write A as negative G. So we can cancel minus and minus. So T would be V naught sine theta over G. Okay, that's the expression. That's what the question is asking. So we don't need to actually find a number. And then part E is asking calculate the horizontal distance x max in meters that the ball has traveled when it returns to the ground. Okay, so we want to find the range. So that's what we want to find, x max, or you can say R also. So to find that, we have this formula. So delta x is equal to, we have this formula for velocity. Velocity is delta x over delta t. So delta x is Vx times delta t, or just t. So we can just write delta x is equal to Vxt. So Vx, we already know Vx, so that's V naught cosine theta. But we don't have T, okay? So we have T for maximum height. So maximum height time is from here to that, there. But we don't know how much time it takes to get from this initial point to the final point, okay? So first we need to find time. So let's find time. For time we need to use vertical motion. So for vertical motion, and in this case the vertical motion is this complete path, okay, not just the halfway, not just to the highest point. So for the whole motion, delta y would be 0 because it starts from here, that's the initial height, and it ends at the same level, so that's delta y is 0. And then a is negative 9.8 meters per second squared. And then what else we have? So we also need initial velocity here, so we need VOY. So VOY is VO sine theta. Okay, so what you do is you find this first. VOY is VO, which is 25 meters per second, sine 15 degrees. So find that, and then use this formula to find time. So delta y is equal to VOY t plus 1/2 AT squared. So that's 0. VOY is whatever you get from here, you plug that in here. Okay, that times t plus 1/2 negative 9.8 meters per second squared times t squared. So you solve this equation and get t. Okay, and then once you have t, now you go back to this formula and then plug t here. Okay, so plug this t in here, and that will give you delta x, and this delta x is what the question is asking, x max, the maximum range. Okay, so please complete this, and if you have any question, please let me know.